Welcome back. It's Tom O'Kee with SCDVA.org. We're here at the Tucson Convention Center for the astronomy show. It's the Arizona Science and Astronomy Expo, the first inaugural show. We're here. It's November 11th, 2012, with Dean Koenig. He's the owner of Starizona, a really fantastic astronomy shop that everybody wishes they had in their own hometown. It's in Tucson, so you're just going to have to come here. As we saw when we were there yesterday filming, we saw that there was all kinds of things that Dean offers. Not only does he build these fantastic products that are accessories for telescopes and telescopes, he repairs everything as well. So if you got a broken telescope, this is your guy. But I want to talk about the stuff you've made, Dean, and the things. And so everybody, Dean's going to walk us through his product line. We're going to start with the Hyperstar.
Well, Hyperstar is probably one of our most novel items. This is sort of an extension from what Celestron started years ago called the FastStar system. It's just a better mousetrap. We're able to deliver a bigger image. What we have here is we're able to use what we call prime focus. So we're actually having light go through the corrector plate, hitting the primary mirror, going through our Hyperstar lens, which gives us an incredibly flat field, about 10 times better than the scope produces natively at the back of the scope. And it does it 25 times faster. And this is removable, so it's not a permanent thing. The secondary mirror comes out, goes into a holder, the lens goes in place, camera's in place. Whether it be DSLRs, you can use a DSLR on a 9¼ inch or larger, or CCD cameras from 8-inch and 6-inch scopes. So this is fantastic technology. It makes an astrophotographer out of everybody their first night out. So you can take images in seconds instead of hours.
Now you developed this product and it's been moving along and improving with time.
Moving fast up to the International Space Station.
And you're keeping up with the technology of camera design as well. As bigger chips come out, new design on the Hyperstar, trying to fill that chip. More megapixels.
Exactly.
More megapixels, faster,
It's
better.
the easiest astrophotography for the highest quality possible. It's fantastic stuff.
Now you do other things too. Show us some of the other things.
So for SchmidtCassegrains, specifically the CPC models, we make a landing pad. It makes it easier to set your telescope on tripods.
No drop in the scope.
No drop in the scope. We make cool edges, which is a way to force cool filtered air into a telescope to rapidly cool them down. This would go on in place of the secondary. And then the secondary mirror would go here, so we actually are going to cool the secondary and the primary system. So this gets your scope optically stable very rapidly. We make virtual views, so if you ever do public star parties, or if you just need a built-in instrument rotator, you put your diagonal in here, and then instead of having to loosen anything, just grab and turn. Oh, somebody's been playing with it. There we go. We'll loosen the clutch a bit more. Grab and turn. So it's really handy if you have a child, you just reach up, rotate the diagonal down. For adult, put it back up.
Plus it's large diameter, you see.
It's a much larger opening than the standard visual back of the telescope. We also make peer adapters for CGM mounts for Celestron scopes. Optically, we also make something, a really nice SCT corrector and fill flattener. Celestron has a reducer, but it's really not a very good flattener. This is both a reducer and a flattener, f7.5. Goes in any standard SchmidtCassegrain telescope. Let's see, we have autofocusers. So, it's not good to take an astro photo if star images aren't sharp, so this will give you instant sharp stars. Very nice. NASA uses a bunch of them, about 8 of them at this time. So they're very robust, very dependable. We make, here would be the motor for the focuser, so very small, it'll automatically turn that focuser for you. Let's see, we make battery packs. Battery packs are very portable systems, high capacity, so 8.5 amp hours in a lightweight package. That's about all we brought from wares at the show today.
Except, you know what they've got? Their brand new Hyperion telescope. Now this is a truss telescope. You had this as just a tube telescope before.
Correct. It was a solid carbon fiber tube, and now this is the first truss tube version of it. We do make a 16-inch truss tube, but this is the first 12.5-inch truss tube version. Beautiful. What makes this telescope very unique is it has a built-in instrument rotator. So it has a built-in instrument rotator. It has coolers and heaters on the optical surfaces and thermistors to keep track of the temperature. It has 2 autofocusers, one for the primary instrument and one for maybe a guide scope, secondary scope. And we control everything Wi-Fi up to 300 feet away with one USB port. That's all you need to plug in to control this telescope.
Now on the back you've got a lot of gear here. Explain what you've added and what this is all
well, in this
going
case,
on here. Let's
you have an apogee camera with a nice big filter wheel, a remote off-axis guider, and a guide camera. Now this is really the virtue of having a rotator built into a system, because you can automate now where you can zip to an area of the target of your choice for the deep sky object. Then you can rotate the instrument package to pick up a star that you need for your guide camera. And it can be all scripted and done automatically for you. And so that's a pretty good sized payload, and the instrument rotator has no trouble rotating that.
And the quality of the build is just astounding. I mean, Paramount ME came out with mounts and they had all this fancy aluminum anodizing and everything. It's caught on. William Optics did the same, and they pushed the levels ahead again with great finishes. You've incorporated it all. I mean, it really is all there, isn't it?
It's a very robust system that's going to give you a lifetime of enjoyment.
Now I see you've used an aluminum tube here. Is there a particular reason why you've done that and not gone to the carbon fiber there?
Well, we had trouble just getting carbon fiber to meet our specifications. We've gone through a couple of different manufacturers, and so the delay is the issue we have. We just decided to forsake it totally and just go to the strongest carbon fiber and do a truss tube version.
Yeah, it sure makes sense. Well, it's a beautiful, beautiful scope, Dean. It's a spectacular thing, and everybody here is seeing a lot of great products, and Dean's one of the outstanding manufacturers exhibiting here at the Tucson Convention Center here at the Arizona Science and Astronomy Expo 2012. Thank you, Dean.
Thank you very much.
My pleasure.
Thank you.
Thank you, Leonard Holmberg.